Good morning. Today we're going to be looking at a different form of quadratic equations. Up to this point, every quadratic equation you've seen has been in the form y equals ax squared plus bx plus c. This is our standard form for a quadratic equation. But today I'm loosely following the problems that you're going to see me write here from lesson 823. So if you want to be in that lesson in your ebook and follow along, you can. So I'm going to look at problem 79, and the first one they present us with looks like this. This is our equation. Y equals 3 times the quantity x minus 2 squared plus 5, minus 5. We think, because of that squared, that it might be quadratic, but it's not in this form. So the question is, can we verify that it's quadratic by transferring it into that form? And absolutely we can. What we would have to do, we would have to start here with squaring x minus 2. And we could do that. We could do that using, I'm going to write this out, using the old-fashioned method that maybe your parents have mentioned, or maybe Mrs. Huckel or I have mentioned, the FOIL method, where you just distribute everything into the second parentheses. Of course, you could also use a generic rectangle to multiply those out. At this point, I think people are comfortable enough that I'm just going to go ahead and multiply this out, expand it, and this is what we would get. Now we have to follow our order of operations. We are going to have to multiply everything by that 3. So we get 3x squared minus minus 12x plus 12 minus 5, and then I can combine my like terms. 3x squared minus 12x plus 7. So it looks like we've got one form of a quadratic equation there. It looks like this would be what it is in standard form. And I can take that standard form and we can actually go through and graph both of those. And we can see then if they give us the same graph. So I'm going to switch over to Desmos. I've already got the one form graphed. So I'm going to go ahead and I'm going to type in the other form. It was y equals 3x squared minus 12x plus 7. And what we're seeing is that we get the exact same graph. So there's the red one. That's the first one up here. And we get the exact same set of points when we plug in the second one. So yes, we can look at that and say for sure that's a quadratic equation. Let's take a look at some of our key points. So when we look at the graph, we see that the vertex here is 2, -5. The vertex is 2, -5. We've got a y-intercept of 0, 7, and we've got some x-intercepts that are not necessarily friendly. Those would be tricky to try and figure out. In fact, when I look at these and I see these decimals here, what that tells me is if I went back and tried to factor this quadratic right here, it would not factor into nice, neat parentheses. Like I wouldn't be able to write that in factored form. So it's helpful that that we're able to graph this from this graphing form. And I'd also like you to notice the vertex here is at 2, -5. And if you look at what we call graphing form, you can see that there's a 2 and a -5 in there. So I'm going to switch back over to my notes. And when we look at this, let's look at another problem. What if we were looking at the second one in problem 79? It's written in function form, so f of x equals -2 times the quantity x plus 4 squared plus 3. And I'm pretty confident that that's going to be a quadratic equation, because now I'm thinking the fact that I have that x squared showing up The fact that I have that x squared, x is going to get squared, that's what makes it quadratic. And so when we go through and we simplify that, for sure it's going to be quadratic. But if you remember, our vertex up here, our vertex was at 2, -5. And based on those points, the 2 coming from here, the -5 coming from here, I think when I go down here and I look at this f of x, I want to make a prediction. I want to make a prediction about the vertex. And if we look at it, if we try and create the same thing, so it was this that was our x coordinate, so 4, and it was this number that was our y coordinate. So I'm going to predict that it's 4, 3, 4, 3. That's my prediction. And I'm going to go and I'm going to graph that, and I'm going to see if it's 4, 3. So we're going to go back over to Desmos. I'm going to type in this equation. I'm going to have to use y instead of f of x, but that's fine. So y, and that's just because of how I have it set up. Y equals -2 times the quantity x plus 4, quantity squared plus 3. And I look at this, and I look at my vertex, and oh, my vertex is at -4, 3. It's not at 4, 3. So I'm going to head back here again, and I'm going to make this adjustment. So it looks to me like, and it should hopefully look to you, like it is the opposite of the sign that is in front of the number in the parentheses. So since this was positive right here, our vertex has an x coordinate of -4. So I wanted to point that out. So that's problem 79. And I'm going to look at one more from problem 79, and we're going to try this one more time. We're just going to do this prediction one more time. The equation is y equals 1/2 times the quantity x plus 3 squared plus 2. I'm going to make a prediction about my vertex. This time I'm going to pay careful attention to the sign. Now since this sign is positive, I believe that makes my vertex -3, positive 2. -3, positive 2. So again, this number gives us the x coordinate. Excuse me, this number gives me the y coordinate. And I'm going to go then over to Desmos. I'm going to graph it. And we're going to see what we get. So y equals 1/2, times, this is always a little tricky, times x plus 3, quantity squared, plus 2. And I look at my vertex, and the vertex is at -3, 2. So we were correct over here at -3, 2. All right, so they call this form graphing form. They call this form graphing form. And in graphing form, our equation looks a little different. It looks like this. Y equals A times the quantity x minus h squared plus k, and h, k is the vertex. So that's kind of helpful in a situation where, and again, if we go back here and look at these different graphs, our x-intercepts aren't necessarily in any kind of a friendly place. And in fact, our red graph here doesn't even have an x-intercept. So those are all situations where if these were in standard form, you wouldn't even be able to factor them to find our zeros or to find our x-intercepts. And so being able to manipulate and use our graphing form to find some key elements is important. I'm going to take a look now at the problem that they put in 880. So they're asking us to look at this equation that is in, this is in graphing form. So right away, there is something I know from graphing form. I can look at that equation and I know right away that my vertex is at -1, -12. All I have to do is look at it in graphing form. Notice that you've got, let's do it this way. You've got H here, and then you've got K here. So, so that gives us our point, -1, -12. My next question is that I want to find the y-intercept. I want to find the x-intercepts. Now the y-intercept is still fairly easy. We can just, it's not as easy as it was in standard form, where you could just look at c, whatever the value of c is, that's your y-intercept. But certainly we could, for our y-intercept, we could just evaluate where x is 0. So we get our y-intercept at 0, -11, and we could do that at any point in time. We could just plug 0 in for x and figure out what y is pretty simply. We could do the same thing since this isn't factorable. We could go through the same thing. We could put 0 in for y, and we could solve for x. So now, let's take a look at this, because I'm going to go through this one. This isn't something that we do a lot, but it is something that we absolutely could do, and we'll walk through this one more time. We'll try it with 81 as well. But I'm going to walk through the steps. Now, to solve this, I have to work my way in. I have to work my way in to where the x is. So my first step, I'm sorry, I believe I have the wrong equation written down. Let me go back and fix that, because if I don't fix that, this is going to get a little ugly. So I'm going to fix this. This should be 16. Not that we couldn't do it, but I'm not ready to make it quite that ugly for you guys yet. This is 16, and now you really feel like you guys are in my class, right? Since this has happened in class as well. I'm going to fix this, 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 and this. So this is 16, 16, 16. That's -15. All right, this will work out nicer. Okay. So we're going to go through. I apologize for that again. I'm going to go through and I'm going to solve for x. I'm going to start by adding 16 to both sides. So I get 16 equals the quantity x plus 1 squared. Now, the nice thing is here, I can actually take the square root of both sides of this equation, because I know that over here on the right-hand side, that is a perfect square. And I can also take the square root of 16. So that means that x plus 1 is going to either equal +4 or -4. +4 or -4. So x plus 1 equals 4, or x plus 1 equals a -4. And I know that because there are two roots for 16. When you take the square root, 4 squared is 16, and -4 squared is also 16. This starts to look very much like the zero product property now. And I end up with two x-intercepts at 3, 0 and at -5, 0. And hopefully, if I did everything correctly, I now have 5 key elements. I have the -1, -16, 0, -5, 3, 0, and -5, 0, and we're going to go graph this equation and see if that's actually the case. Let's go ahead and clear out some of these other ones. So I'm going to look at the quantity x plus 1 squared minus 16. And when I look at my key points, I've got my x, my vertex at -1, -16, which we already knew. I've got my y-intercept at 0, -15. I've got an x-intercept at 3, 0, and another x-intercept at -5, 0. So sometimes it does work out that we can just go through a solving process and find those pieces fairly easy without having to put it into standard form and then factor it and figure all that out. So we're going to try this one more time. We're going to try this one with 81. And we're going to take a look at 81 and how this works out. And I don't think this one's going to work quite as neat and nice, but you're going to see then how this can become a benefit. And it's actually moving us closer to where we're going to head when our x-intercepts aren't as nice and neat as they have been up to this point, where the zero product property maybe doesn't work out as nice as we had hoped. So I'm going to start with the equation y equals x plus 2 quantity squared minus 3. Clean that up a little bit. And right away, I'm going to identify my vertex. My vertex is at -2, -3. Right away, I'm going to identify my y-intercept. My y-intercept is going to be at 0. When I put 0 in for x here, I get 2 squared, which is 4. 4 minus 3 is 0, 1. And now I'm going to go through and I'm going to find my x-intercepts by solving this equation for x. So I'm going to add 3 to both sides. I get 3 equals x plus 2, the quantity squared. And I know I'm going to take the square root of both sides. So what I end up with is I end up with two things. I end up with the fact that x plus 2 is going to equal the square root of 3, which I'm not going to find because the square root of 3 is an irrational number. It doesn't end, it doesn't repeat, it's just an ugly decimal. So for right now, I'm going to leave it as just radical 3. I also know that x plus 2 could equal the opposite or negative square root of 3. So you have a positive outcome and a negative outcome. I'm going to go ahead and solve these. And now this gets a little messy just because I want to write it out like this. First of all, to just show you, this kind of prepares us to get us ready for what's going to happen when we're using the quadratic formula. And that will be happening soon in situations where we can't easily find those numbers. But we could also punch this into our calculator and we could get approximations, and notice that I'm switching over to approximately equal to. -2 plus the square root of 3 is approximately equal to negative 0.27. And then over here, -2 minus the square root of 3 is approximately negative 3.73. So I do have two approximate x-intercepts. And I can again, I'm going to go in and I'm going to graph and I'm going to look to see that I got those points and see if that's actually what it looks like when I graph it. Let's clear out that top one. So this equation was y equals the quantity. Hold on one second. The quantity of x plus 2 squared minus 3. And when I look at this, and I click on my different points. I've got a vertex at -2, -3. We had that. And if you look at our 2 x-intercepts, those are approximations, so those are correct as well. We've got 0, 1 as the y-intercept, and that's it. So this is just another form of the equation, again, back here, graphing form that can take us through the steps to find those key points in a different way. In terms of homework tonight, we're assigning 85. 85 is going to have you go back through with the, it says solve for x, which means you're finding your x-intercepts. And then 86 walks you through a few different places of finding key points. We are not yet going to have you practice with this graphing form, but that will be coming soon. So hopefully this made sense, and if you have any questions, you can contact your teacher through Google Classroom. Thanks.